Um, so yeah, machine learning on Azure, and this is me here, right on the left. I just got a little younger and I shaved my head. No, I'm just kidding. I'm not in any of these photos. But this is what I intend to cover today, right? So, yeah, we'll talk about the workspace, and I'm going to give a bit of context about Azure Machine Learning in general and why I'm focusing on the workspace. And we're going to give two examples, right? One that is a classification one with the IBM attrition data set. So, employee profile, whether or not that employee left to go work in another company, and I'm going to show you a forecasting example as well. So orange juice sales broken down by brand and store. And we're going to look at this in the context of Azure Machine Learning. Now, I'll take this approach here. We'll look at the no code and the Python code experience, right? There are other things that we can do here, of course, and there's something in between here that maybe some of you have used. There is the studio where you can drag and drop and connect things. So kind of do a visual development of a machine learning model. I'm going to skip that for now. And why? Because I'll go to two extremes because these are the ones that I see getting more traction in the market, right? The no code experience for automated ML. So it's really like wizard like, good for business users with some caveats, right? We'll talk about that. And then the other extreme, you might as well just jump in and actually get a notebook and get coding in Python, right? It's not too hard, not a lot to learn, and a lot to gain, right? So I've been working with these two sides of this coin more often than anything else. And of course, today it's going to be a fast, big picture approach. I actually use a similar presentation when I'm talking to customers that bring in, hey, we have these data scientists, we have this, more data science happening in our company. What can we do in Azure, right? What can you do to help? And this is the commercial slide, right? You probably know this, but yeah, data, AI, cloud transformation is everywhere. And if you want to throw some numbers there, I mean, large companies that use digital transformation, right? So they're trying to do things online, automate process, use data. They have more operating income, right? So this is about the bottom line, of course, and generally speaking, right? If you use data, use technology, use the cloud, there's a tendency to have more revenue per employee, right? So those are the numbers. Keystone strategy, 2016. This is probably bigger right now. Okay, so in our context here, yeah, great. We have data, and then somebody said, hey, if we add AI to our products, then our company is going to be worth more. Fantastic, right? Now it's up to the technology people to do something about it. And usually, I would say these three key problems, right, that the company has to solve. So number one, build a unified and usable data pipeline, right? I was talking to a large company in the hospitality industry, right? And this is what they're struggling with, unified. They have loads of data sources, 30, 40, 50 data sources. They have data sets with 400 million, a couple of billion rows. And then you have loads of departments, right? They probably have upwards of 30,000 permanent employees, right? So several brands, several departments, several like IT pockets. How do you unify all of that, right? And how do you make that usable, right? And then, yes, pockets of data scientists doing their own thing in laptops, training ML, and then how do you operationalize this, right? How do you do batch inference and then make the results of those data models available. This is the backdrop, right? This is what the companies are sort of trying to solve, right? Yeah, exactly. So Victor is making a very relevant comment there, right? Usually, what I see in the companies is precisely that. Unless you have a push at the right level of the company, right? If it's too low at the director level, it's probably not enough, right? If it's too high at the executive suite level, probably not enough, right? So you need some sort of coordination, right? Some VP of data that will be happy to push for this unification. A couple of directors that are on board, and then you create this momentum, right? And then you start to make useful data available to more people. You start to share pipelines, right? And again, this is probably another thing that you know this, right? This a lot of these things are not simple. When it comes to ML, what do you use, right? PyCharm, VS Code. Do you do things locally in your laptop? Do you have Macs? Do you have Windows the laptops, right, for your coders? What are they using? Do you use Git, GitHub, Bitbucket? So there's loads of stuff out there, right? Frameworks, and just in the data pipelines alone, you can use a lot of stuff. But also, you could have issues here with granularity, right? I worked with a large distributor of beverages in South Florida, and that was the issue that they had. Sometimes they were trying to do machine learning to predict how much of their product would go through the large distributors that they partner with. And the issue was, well, sometimes they would have daily sales data, but sometimes they would only have monthly data for certain states, right, within the U.S. And then going to other countries, it was even crazier, right? But the granularity there of like monthly data would force them to go monthly. But then they were trying to do forecasting, but they only had 3 years of data. So then 3 times 12, you do the math, right? Very few data points, hard to do like really accurate forecast with that small data set, right? So a lot of times you have these issues. Not that you don't have the data, but it's monthly when you would like to have it weekly, or it's weekly when you would like to have daily, or it's daily when you would like it to be hourly, right? So that matters as well. And scalability is another thing that I see in the field a lot. So people put together a solution, mash up, works for a year, amount of data grows, new stores come online, and then the solution starts to break, right? So what do I do? Or that classic thing, right? It works on my laptop. So of course, the idea of the machine learning workspace is to provide a solution for that, right? So there's lots of solution areas in data and AI in general, right? For data, I'm just contextualizing. We're zooming in on solutions related to machine learning. That's what we're talking about today. Okay, and of course, there's a large data science and machine learning portfolio. This is the summary. And again, we're zooming in on the machine learning workspace, which is one component of this big puzzle here, right? And we're taking the productive services angle, right? So why do people adopt that? Come on, you can train your models on your laptop and then later containerize that and then run this anywhere, right? Why would you pay like a small premium, or why would you pay for cloud compute for something that you can do in the laptop, right? This is about the argument here is productivity. And that's not Rodrigo saying. This is the reasoning of teams of data scientists making decisions, right, and picking this. But of course, there's a lot of other things available. We don't have a lot of time today to talk about that, but happy to discuss this in a future presentation. So let me just use a pen here, right? So if I talk about these domain-specific pre-trained models, right, this is cognitive services. Have you guys worked with cognitive services before or no? Anyone? You can put a yes and no or no in the chat, so we make this a little bit interactive. Yeah, you did, Armando. Awesome. Okay, so yeah, there are different categories of. So these are REST APIs that have a pre-baked model, pre-trained model available for you to use, right? I think the second line here, it's an important point. You can bring your own tools, right? So you could, yes, develop your model in PyCharm and Jupyter, and then we'll talk about a Python SDK a little bit later that would allow you to interact with this this Azure Machine Learning workspace, right? So yeah, you can bring your own tools. You can, where's my mouse? I don't know. Okay, you can bring your own tools. You can use your own frameworks, right? PyTorch, TensorFlow, Scikit-learn, right? Whatever you want. Onyx is a way to represent a neural network that is interchangeable, so you can run it on different hardware. Right, so you have all these things, and of course you have different kinds of hardware, right? CPU, GPU, I'm sure you heard about that. For deep learning, GPUs are more appropriate. And FPGA is excellent for you to do very quick inference, right? GPU is good to do inference in batches. FPGA, generally speaking, is better if you need like one inference at a time, right? So tell me if this customer is at risk right when I pick up the phone to answer that phone call. So FPGA is good for that kind of stuff. GPU is good for batching. So calculate the customer churn probability every night and then push that to my the customer management system, right? So anyways, we also have two more services that I see out there, right, in South Florida. Pretty much every large customer that I work with is using Databricks in some way, right? Sometimes small, sometimes it's a central part of what they do, especially with data transformation, right? With ETL and using Spark to move and transform large amounts of data. And then this bit here is disappearing, right? This part here is becoming part of the AML learning workspace. We'll talk about that in a minute. All right. So with that, I'm going to give like 3 seconds in case you have any questions about this. No? Moving on. Okay, so what can you do with this Azure Machine Learning, right? When I say, okay, so Azure Machine Learning is a set of services, right? It's services, capabilities, things around machine learning, and you will find these things in a machine learning workspace in Azure. What can you do with that? Okay, so four major capabilities, right? And a lot of this is related to traceability. You create a model, you want to predict something, and then you want traceability on that model, right? So I don't know if you, and this is getting more and more important. I think it will be the theme, right, of the next 12 to 18 months for sure, 12 to 24. But traceability, interpretability, right, that's the next wave, right? We were discussing frameworks, right, a couple of years ago. Then we were discussing DevOps and tools. This was like last year, right? And what is this year and the next? Accountability, traceability. What is this model? What is it telling me? Is this model biased, right? Is this model, because a model could be racist if the data is racist, right? A model could be biased if the data is biased. I don't know if you heard the story about the Apple credit card, right? That became quite popular, but essentially they use a machine learning algorithm to suggest the credit limit for each person depending on the profile. Of course, when you issue a credit card, you want to give the person the highest credit limit possible with the lowest probability of default, right? So that we have these two, yeah, exactly, on mitigating. Thank you, Victor. A very good presentation on mitigating bias. That's good to know. So yeah, in Azure Machine Learning, what you can do is you can register your data set, okay, and then of course you can train your models, and of course you can evaluate your models, see which features are important, which are not, and then deploy, and then have full traceability here, right, from end to end. So what was the data set that was used? What was the model? Who trained? Who deployed? When? Right? And how it was evaluated. Okay, so let's get started, and then let me show you a couple of things in the Azure Machine Learning workspace, right? So we're going to look at three things here: notebooks, automated ML, and the designer. Not so much, right? I'm just going to mention that, but you can do that in Azure Machine Learning. Nothing against that capability, right? It's just that I have seen more interest in the first two. So, like I was saying before, if I go to the portal and I say, hey, I need to create a resource, right? I could go to AI and machine learning and then pick this thing here, or I can search, right, for machine learning. Okay, and then pick this first one in here, right? Now, you see, this is the new logo. I'm going to show you something interesting in here. If I go to create a resource, Azure Machine Learning, or if I go to machine learning, yeah, okay, that's what I wanted to show. The machine learning studio classic. You see this one here? You have sometimes the classic one. This is the old product, right? So if you're starting something right now, you definitely want the new one, the one that you see here, AI machine learning and machine learning, right? So you can create this resource. Once you do, you end up with an object, right? Let me show you here. Let me go back to the portal, and I have one that I created in here. Okay, so I'm going into one of the resource groups that I have, and here we go. You see this machine learning workspace, Devo 1. So this is my machine learning workspace that I created, right? And you have the older experience here on the left. So you can see experiments, pipelines, compute, models, and images. You can still use this, right? But I'm going to focus on the new machine learning studio. And everything is a studio these days, right? So this is no exception. All right. So those three things that I said: notebooks, automated ML, and the designer, right? So when you create this, okay, what will cost you money here? What you see on compute, right? So if I have a compute instance that is running like I am right now, right, depending on the size of it, that's what's going to consume money and cost in here, right? So if you create a compute instance, you could of course work. When you're done, boom, you could stop it, and then you come back tomorrow, you start it, work, and then you stop it. This would be the most cost-effective way here. You also have compute clusters. We're going to talk about that later. This is different. This is with the like a remote execution. Really good, really practical. You can scale like crazy with this, right? And as a general rule, what I recommend and what I see also some customers use is to have a relatively small compute instance, and you can think of it this as your a data scientist computer in the cloud. That's for you. This one, generally speaking, would not be shared. If you have 5 data scientists in the company, you would see 5 compute instances, one for each, right? What is the benefit of this thing is that it comes with a whole bunch of libraries, including, of course, the Azure Machine Learning SDK, the software development kit, and you could, let me give you an example here. So I go to this guy. Right, so you see I'm opening up the notebooks. So every notebook would be attached to a compute, you see here, right? So this is like my data science laptop in the cloud, lots of libraries pre-installed. And when I do workshops, for example, I was doing a workshop on cognitive services in one of the customers, yeah, 20 people that needed to get up and running fast. We can do a setup like this, creating 20 compute instances in the cloud super quickly as I'm explaining things, and then everybody will hit the ground running. Okay, I tried the same thing with people installing the required libraries on the laptop, right? Ooh, they had different laptops, Macs, PCs. It's a nightmare. It will take a much longer time, right? Of course, if you know what you're doing, if you automate, you can do things on a laptop, but in large enterprise environments, this is a blessing, right? The fact that you can create this, you have a whole bunch of libraries already pre-installed, and then you can get an example. You see, you come with a list of samples from the cloud, and then you can run this, and the notebooks work without a lot of sweat, right? This is the kind of stuff that I have seen. I know it sounds silly and it's relatively simple, but this is the kind of stuff that makes that team that maybe is savvy in terms of data engineering, right? Transition towards more of data scientists, right? They really know the business. They're really subject matter experts, but they're getting their feet wet in the data science world. This is something that accelerates the process a lot, right? And guys, feel free to chime in. I appreciate I'm speaking from my personal experience, but by all means, if you have any questions, you want to know anything in particular, let me know, right? So what did I say so far? So you have notebooks, so you have samples, of course, right? A gallery of samples. I'm going to highlight just some of these during my presentation today. And then you have kind of a file system, because when you create this machine learning studio, you create a storage account. And then that's where these notebooks live, right? So, but notebooks, this IPYNB, that's just the code, right? You need something, you need some compute to run that code. That's where the compute instance comes in, right? So let me see what else I wanted to show here. So compute instances, this is one thing that I wanted to say. And then there is the compute cluster and the idea of local versus remote. Okay, what is that? What is that? What is that story? Oh, sorry. Here. Okay, so if I go back to compute, we already know that this compute instance, that's where I have my Jupyter notebook server running. So if I go back here to notebooks, if I run anything on my notebook here, you see that's that same strange name that I created, right? So and this looks a lot like Jupyter. Some would argue a little bit better, but if you really say, hey, I don't like this UI, I want to go to the old UI, that's fine. You can just select edit in Jupyter. You're using the same compute, you're using the same storage account that has that notebook, right? But now you're seeing like the native Jupyter. And as you probably noticed, I was logged on automatically, right? So all my credentials are kept. See, very similar, but now this is the Jupyter experience. All I see here in the Azure Machine Learning Studio, it's a wrapper, right? And then I can run each cell, one cell at a time, right? See, it's running here. And then it's going to spit out the SDK version at the end. There we go. This is important, right? If you're troubleshooting, to know which SDK version that that you are using. Okay. So let me close this. I was talking, okay, local versus remote, right? You have different types of compute and you have compute clusters, right? The way that I see this used is, for example, there was this company here. So they were training a model and they wanted to do prediction, right? So this is in the hospitality industry, and they want to predict which bookings will cancel and which ones will not, right? So you say, hey, I have this date here. I have, I don't know, 4th of July weekend. Tell me from the bookings that I have today, how many, which ones or how many do you think will cancel before the 4th of July, right? That's important because then they can run promotions and so on. Now, the issue is that the data set was about 400 million rows, and it wouldn't fit on this compute instance, right? So, like I said, to save money, because this is running many hours a day, usually you want this compute here to be relatively small. But then what they wanted to do is they wanted to try a whole bunch of algorithms and a whole bunch of combinations with that data set of 400 million. And for that to work, they needed 256 gigabytes of RAM. So what they did is that they created a compute cluster, okay, that was larger with each node 256 gigabytes. They allowed the cluster to go up to 8 nodes, right? Yeah, that's good. Victor is saying loves the classic. Yeah, I know, man. Now I started to use this, and then I started to love this one here, right? So I would say try it. Maybe you will like it. I think like 8 months ago it was a bit of a love-hate relationship, right? Because they were still working out some kinks. I think right now it's pretty decent. Okay, but yeah. Anyway, so they had these 8 nodes, 256 gigs of RAM, and then they could very quickly in 2 hours just try 60 different combinations of machine learning training models, right? So they were really happy about that. So of course they only paid for this large cluster, 8 nodes, 256 gigs of RAM each, for only those 2 hours, right? And the compute instance was tiny. Keep that in mind, right? I think this is important to understand the difference between these two. Okay, so compute instance, it will be running usually either 24/7 or maybe you shut it down automatically with an Azure function. I don't know, 8 p.m. and then you bring it up again at 8 a.m. Right? I see companies doing that, but I also see people just leave it running 24/7. And the compute, because the compute cluster, the cost, right? The bulk of the cost is here. And this one, you can set it up. You see how this one here has 0 nodes active? So I'm not paying for compute at this time, right? So the compute nodes, they would scale up and scale down automatically, right? That's the beauty of this thing, the beauty of this split, right? Okay, so how do I know if things are running on my compute instance or if these things are running on my compute cluster? That's where the story, local versus remote, comes in, right? So remember, local versus remote. So in my notebook, let me show you an example here. So you see, if I run this piece of code here, just like I did, right? I hit run. Nothing here tells me that this print will run remotely. So it's running locally. What does that mean? Because this is in the cloud. What's local? What's remote, right? Local means in the context of this notebook, right? The server that is serving this notebook and processing this notebook is the compute that is being used to process this print. And the same story goes here if I keep going. Right now here, I'm creating a compute cluster on the fly. It's fine if it already exists, right? If it exists already, we'll ignore, right? It will just keep going. But I'm standing up a compute cluster. I'm saying that here's the size, right? It's a DS12, kind of beefy, a little more expensive. And what's the maximum number of nodes here? 4. I'm allowing it to go up to 4 nodes, right? If I look at, this is an automated ML. I'll talk about that in a minute. But if you look at the run here, right? Look at the configuration here, the compute target, okay, is this compute target that I created up here. See?
Rodrigo, can
yes.
you make it a little bit bigger?
I can. Thanks for bringing this up. Oh yeah, let me just minimize this guy here.
It's better.
Yeah, sorry. So you see, I'm creating this instance of ML compute. You see, I'm using Azure ML call. When I say the SDK, this is the library that I'm talking about. I say SDK because you could download it and run it locally on your laptop. You could install it on a Databricks cluster. In other words, you can use it from anywhere, right? And then in my case here, I'm sending the this automated ML run to my remote cluster. So in the settings of my automated ML, I'm saying, hey, run this on this compute target that is the remote cluster. So I'm not running locally, I'm running this remotely. That's what makes it use the bulky server. And you could apply this logic to your laptop as well, right? I see this less often, but I can think of at least one company that did this. They said, oh, you know, we want to keep our development in our laptops, but yeah, from time to time, we need a machine with a 0.5 terabyte of RAM. So what they do is that they issue a remote run. Of course, in my example here, this is automated ML, but I could set up a Python script and say, hey, cluster, go out, run this in the cloud for me, and give me the results, right? So is there anything that I'm saying that makes sense? I mean, is this too slow, too fast, too basic, too advanced? What do you think? Or any questions, any comments? No?
I have a question. Would you set up a remote environment, compute environment for each workload that you're doing, or would you simply have one and send it different things to work on?
The latter. You could set up one and send different ones, right? Now, one thing to keep in mind is that this is easy to set up and break down. So you can think of it as like a disposable resource, right? It's really legs for your project. So yes, I tend to share across different things, right? So I know that, look, this is my monster cluster, and this is my regular cluster, right? So I will send, like, the monster one is 256 or 512 gigs of RAM, and then I have my regular one, right? And then I balance between the two. I call one or the other depending on what I need. But I normally use code very similar to this one here, right? Where I literally copy and paste this cell. And this is in one of the examples in there. I'm happy to share the link for that one. But you see, I check, hey, is this computer available? I said, hey, and then Siri woke up. If it doesn't exist, I'll just create it, right? And then I just edit this string here when I go.
Do you have to wait until one workload is done before you send it another one, or can you just keep sending them and it takes care of the queuing and everything else by itself?
It will not queue, right? It will run both at the same time. So yeah, that's one thing that might motivate you to maybe give a slightly different cluster name. Like, I was in a project and I wanted to test the timings with different cluster sizes, right? So what I did is actually, this is why I have this -B here, because I had like the A and the B, and I wanted to run both in parallel. and I didn't want them to interfere with each other. So good question. All right. So anything else? All good? All right. So okay, I want to say just one more thing here, because Victor, you still have something that is similar to the designer or to the classic drag and drop and connect to create ML models, right? Which is this designer. Now, this designer was rebuilt from scratch. So the classic one will have slightly more functionality. This is catching up. To be honest, I don't know how far it is, right? But a few months ago, it was a little bit behind still, right, in terms of functionality, because it was a rewrite. It was not adapting the classic edition to this, right? But the promise here is to have something that is fully integrated in this nicer environment and so on, right? And of course, all the results of the experiments would pop up here and everything else, right? The models that you save and endpoints would end up in here. So the whole idea or the vision here is to integrate everything into this new UI, okay? Now, the other thing, let me just go back to my guide here to guide to make sure that I don't miss any of these topics, right? So about the workspace, you can control this. You have the role-based access control, of course, for the workspace in itself, right? So the workspace is a security boundary, right? So if I go back to the portal, right, and if I go here, I go back to my dashboard, and let's say I'm searching for my machine learning workspace, right? Okay, so look, I say, hey, show me the machine learning workspaces that I have. So I'm browsing for these resources inside of the Azure portal. So I come into this one here. Here we go. This is the resource. And you see I have access control. This is the RBAC, role-based access control. So I could here create a role. So I don't know, revenue planning, revenue management, marketing, right? So those groups could have could be assigned access to the workspace, right? All right. So that's one thing I wanted to show you. Another thing, just a quick one. We have data stores, right? And I have mixed feelings about this one here from the customer side, right? Yes, it's a great idea in terms of keeping track of your data sets, but a lot of times they're like, well, you know what? I have my data set in my data lake. I have my system to tag those data sets. I don't want to use this, right? So maybe they make some data sets available more for training and so on. But the purpose of this, check this out. I'm still in the workspace, right? If I go to data sets, I could register a data set, right? So this could be, let me show you here the sources, right? It can be a local file. So in that storage, that storage that is attached by default in this machine learning workspace, or it could come from a data store, right? Yeah, a table, right? A file, a Parquet file, right? So I could have any of these things here. Let's give it a name, right? And then I forgot to say this first, right? You have the concept of a data store in the workspace. The idea is to make things easier for your data scientists, right? So, how, you know, again, large enterprises, people coming in, contractors coming in, people going out, right? How do I connect to my data lake? Do I need oh, give me the credentials. Oh, I have to talk to IT. Geez, you know, it takes a week to get that stuff resolved. If instead you have a workspace, let me close this for a moment and then show you the data store, right? Because I should have shown you this earlier, right? Before the data set, let's talk data store. So if I define, for example, this is my data lake Gen 2, right? Blob storage with a hierarchical namespace. So I define the credentials so people have this access to this uh, fully enabled playground, right? They can just make with one line of code, again, part of the SDK, you could you could say, hey, I want to get a file from this data store. And the name of the data store could be like data lake. So simple, easy for people to understand. Credentials are in there. So you make this playground concept easy, right? Of course, it works for Gen 1, works for Gen 2, works for Blob as well, right? But where was I? Oh, data sets, right? So when you create a data set, you could import it from a data store. Now Microsoft has this open data sets thing. So for example, there is a COVID data set that is available if you want to do machine learning experiments on it. Okay? The idea is to have this open shareable data sets, but the point is when you create a data set like this one here, let me show you. This could help you. Maybe you have a couple of reference data sets for your enterprise, and you have a profile, right? You have some statistics on the columns. You have a nice UI for you to look, right? At least have a quick look and see what is that data set all about, okay? And in my example here, employee attrition, I have, like I said, the employee profile. Look at this guy, 41, it's a baby. And travel rarely, right? And then education level, hourly rate. See a lot of profile stuff here. And then in some place here, you have whether or not this person left. Oh, is it the first one? Oh, attrition. Yeah, here we go. Left the company, true or false, right? So this is a nice thing. I can browse my data set, and if I create an experiment with data set, I will have full traceability, right? Data sets can have versions, and so you would know that you trained this model with version 5, not with version 7, right? This can be quite useful, and you're not going to import this into the workspace. No, you can make a reference to your data lake, right? So it doesn't take space in anywhere other than where it's already located, right? So it's a nice way to keep track. I don't see a lot of adoption on this side, but hey, I think it's getting better and better. Maybe people will start to jump in. All right, so switching back, just to make sure, yep, I talked about these things. Right. Fact or fiction? That's a good question. I mean, I take it at face value. I mean, it is. I think it's from the 90s, I believe, and yes, it is one of the. I think it's one of the data sets that is even used in Kaggle competitions, right? It's supposed to be real, yeah. Okay, so again, just giving some context here, right? Because before we had like the DSVM, the data science virtual machines. Today we have this compute instances and training clusters. There's this split, like I was explaining. The other common question, actually, I answered this question today. Where do I draw the line, right? I have Databricks in my company. I have folks that like Spark, but I like this machine learning thing. Where do I draw the line, right? It really depends. I mean, if really high level, one thing that I would ask is, okay, like an easy way to think of this is, okay, your Spark data engineering naturally fits in Azure Databricks. You're not going to do like large data set engineering with pandas, right? You're going to run out of memory. It's going to be tricky, right? So data engineering probably would live here in Databricks or Data Factory for that matter, right? And then you land your Parquet file in your data lake and you pick it up from your Azure Machine Learning. Okay. Oh, so what do you do? What do I do in machine learning that I cannot do in Databricks? Well, technically, yeah, you could do model training in Databricks. Of course you can, right? Where does it become interesting to do it in Databricks? Well, if you want to do distributed training, right, ML.NET, then you definitely want to stay in Databricks, right? Or if everything fits and you don't find it's nothing too esoteric, too new, or too that requires many libraries, right? Then you can probably stay in Databricks and be happy in there. The reason why I see people move to like a more Jupyter-like workspace is once you start with things like, hey, I saw this paper on the internet, I want to give it a try. I want to see if this forecasting methodology here will lead to better results for us. Then they start to bump into issues installing libraries in Databricks. Of course, you could have your own image. There are ways around it, right? But you could lose agility, right? In that case, what I have seen people do is that, yeah, data engineering is still here in Databricks. We love it. But then I land my Parquet file, and then for more flexibility in terms of libraries and all that stuff, then I use machine learning. I use the Azure Machine Learning compute, right? Compute instances that I can just install whatever I want very quickly, no fuss, right? And also relatively cheap because it's a single node, right? So it's one way to go, one way for experimentation. So they're not mutually exclusive, and I see more, quite often, if not every time, right? Both coexist happily, right? So you can do that, no problem at all. Okay. So it has been, I think, an hour, right? I can show you this no-code automated experience. This would probably take 10 minutes, but then attrition, factor fix. Is that really a public data set? Victor, are you asking if the data set is public or if it's available? Are you looking for a link?
No, I'm not looking for a link. I mean, I'm looking at right now what you're writing here, so I mean, I'll look for it myself. But I appreciate the. I mean, it's a little. What's the word I'm looking for? Interesting. Let's just leave it at that.
Okay. Yeah. Yeah, I thought it was real, but you raise a good question. We always need to have some level of skepticism, right? But so let's have a look at this, right? So if I go to automated ML, remember I said I was going to show the no code. I showed you a bit of the notebooks. Now let's take a step back and then think, okay, I have this subject matter expert in the company that wants to collaborate with a data scientist, but instead of trying to do like a brain transfer between the subject matter expert and the data scientist, maybe the data scientist could help the SME understand a little bit about the automated ML, and then this SME would spend some time and then come back with ideas that have legs so that the data scientist can take that further, right? So the whole theme here is to democratize AI, or to enable larger parts of the company to accelerate this AI or machine learning, specifically machine learning adoption. Okay, so this will not solve every problem. It does not replace a data scientist, right? But I have seen companies use this in two ways, like empowering SMEs so that they can bring selected proposals, right, or more qualified proposals to the data science team, or the data science team can more quickly iterate and try to find, for example, which features matter, which features don't, which algorithms are worth spending time tweaking, right, and doing hyperparameter tuning. Okay, so I'm going to create an automated ML run. What this thing is going to do is It's going to take my data set, and then it will try combinations of three things, right? The feature selection, right? Different feature selections, different pre-processing steps, and different algorithms, right? So why different pre-processing steps? Because sometimes you need to, for example, normalize the data that is coming in, right? So if my neighbor is Warren Buffett, that's going to distort or the average income of the whole neighborhood, right? So you might want to eliminate that outlier. You might want to apply some statistical treatment there so that you don't skew the data too much, right? So this is pre-processing, and there are many. There are maybe, I don't know, half a dozen different types of options. Not every one of those options match every algorithm, right? So then algorithm, you have, I don't know, random forest, random trees, you have anything from deep learning to like traditional regression models. So which one should I pick, right? Well, so what automated ML will do is that it will look at the characteristics of your data set, statistical characteristics, right? Standard deviation, average, minimal, maximum, median, all of these things, how varied the data is, right? How many unique values you have. And then it's going to use something that was developed by Microsoft Research, because they had the same problem, right? I have a data set. What is the best combination that I can use to have a decent machine learning model, right? And what they did is that they started to keep track of the experiments, and then they noticed, of course, there's a mix of past data, right? All the machine learning training that has ever been done inside of Microsoft, but also some theoretical input, right? Because you know that, well, if you're trying classification and if your data distribution is X, Y, and Z for this and this and these features, you probably want to ignore those features and focus on these, right? So there are like rules. All these rules are embedded, and automated ML will prioritize the combinations that are more likely to give you a good result, right? Azure ML or Databricks, right? Both. That's the answer. Do both, right? I'm happy to talk a little bit more about that as well. But let me show you how this would look like, right? So I'll take this IBM employee attrition, and I'll have to research this, Victor, because now I have this in the back of my mind. Is this real or not? I need to know. So I'm going to create a new experiment, right? So for example, my user group experiment. So this is the target column, right? It's the attrition. We looked at this data set before, and now I need to specify what is my training cluster. You see, it didn't even ask me for a compute instance because it knows that those things are small. Okay, I want a compute cluster, and the number of nodes here matters, right? Because if you give it 8 nodes, it's going to try 8 combinations at the same time, right? 8 combinations of, remember, the feature set that is selected, pre-processing, and the algorithm that you're using. So I'm going to hit next, and today automated machine learning can do 3 things. 3 types of problem: classification problems, regression problems, and this one is a little bit newer, time series forecasting. And if you look it up on documentation, you'll see what algorithms and pre-processing steps each of these will take. This one is new, enabled deep learning, and it's super cool. Not like 100% ready for prime time, I have to say that, but one cool thing that this will do is that, imagine that you have a column there with unstructured text. I don't know, a review or a comment or paragraphs from the first email that this employee sent. If you enable deep learning, automated ML will featureize that unstructured text using BERT, right? A natural language processing technique to extract topics out of it and include that in your classification. That's super cool, right? And then this could, for example, for ticket routing, right? Support ticket routing, that kind of problem. You receive a support ticket. Is this going to go to team A, team B, or team C because you have specializations, right? This would make things incredibly easier for you. Other ways of doing it, but I think this is pretty cool. And of course, this would allow you to use deep learning as one of the algorithms. Okay? And of course, using a compute cluster that has GPUs would speed things up if you enable deep learning. You have regression. Okay, so classification is if you have an outcome like this one. Yes, the employee left, or no, the employee did not leave. Or if you have a support ticket routing, should this go to the hardware people, to the software people, or to the everything else people, right? So you have three classes that you're trying to predict based on the features that you have in the output. Regression would be you have a bunch of features. Tell me what is the price of this house. You know how Zillow gives you a Zestimate, right? That's an example. So you predict a continuous numeric value, and then you have forecasting. Tell me how many units of orange juice you think I'm going to sell in the next week. Okay, and again, you have features. And one thing I always like to point out, you can put the exit criterion, right? Actually, this should be criteria, plural, because I have more than one. I can say, hey, I will give you my cluster, and remember, this is money, right? How much money are you allowing the automated machine learning to spend? Okay, I'll give it 3 hours, right? In that 4-node cluster with 128 gigs of RAM, do the math, that's it. But you could also say, look, if you reach 95% accuracy, stop. I don't want to waste money trying to find something better than 95, right? So this could help you optimize your compute time. So you hit save. Once you hit finish, the automated ML run will be created. The cluster will get all the prerequisites installed. The number of nodes, in this case 4, will spin up and start processing this, right? Each of the nodes, because I'm referencing a data set on a data store, they will have the data store mounted on the node, and then they will pull the data directly from the data lake, and then the magic will happen, right? Yeah. Oh, data set links. Okay, we can do that. I'm going to do like those baking shows because this would take 3 hours, right? So I'm going to go to an experiment that I have done before. I'm sure I have done this employee attrition before. So here we go. This is the output, right? This is the output of a run that I did on this experiment. You could have multiple runs, like in that case that I said I was trying to see what was the optimal size of the cluster, CPU and RAM. I was trying to, to give a good answer for the customer, right? And give a recommendation. Should you subsample? Should you use like a larger cluster, smaller cluster, based on the time window that I had as a requirement? So I did several runs with different cluster sizes, and also with tags. You can tag each of these experiments so that it's easy for you to find stuff. But at the end of the run, you will have like a list of models that were attempted, right? So look, in this case here, I was able to reach 91% accuracy, give it or take, using max abscaler as a pre-processing step, and using the SGD algorithm, right? If I click on it, you can have a look, right? And then I have a whole bunch of metrics here that I can use to evaluate. Okay, so it's complaining about like some configuration here that I don't care. Hang on, because I think this is too big. Why am I not switching? Not showing my metrics. Oh, yeah, okay. So they're just, so you have all these things that you can use to evaluate your model that are calculated for you by default and see, is this model good? Is this decent? Is it not? What I like to show is this one here, but this one doesn't have any explanations to show. Let me just go back to this run and get the main one. Is this the one? No. I want to show the explanation. Hang on. But obviously I don't have this one here. I should have. Hang on, I think on this one. So they always have the models as an output. Yeah, here we go. This one has explanation. So the voting ensemble, a combination of two models was the best. Appreciate we're a bit over time, but then I'll just show you the explanations, and I think with that we can take some questions and wrap up. But the idea of explanations is that when you generate a machine learning model, we have like two categories of models, right? The glass box models, which means you can look inside and clearly see what's connected to what. A regression model, a linear regression model, is an example of a glass box, right? Because you just see how much each variable will interfere in the output. It's literally a mathematical formula that you can read and understand and interpret, right? So glass box. And then you have the other ones, the ones that are not glass box. So there isn't a clear way to see how the outcome is defined, right? So for those cases, for the non-glass box, what you can do is you create a model on top of that model. You assume that that's a black box, and then you play with the values that you enter in that black box, and you watch the output, how the output changes, right? So you create a model on top of the model, and then you can do things like this. What is the feature that is the most important for this, right? So this one here is a different data set. Sorry for switching data sets on you, but this is a bank marketing data set. So yeah, I have the customer profile, I have marketing conditions. Telemarketer calls you and asks, hey, do you want to deposit? Do you want to buy a certificate of deposit in my bank and then make 2% a year? Yes or no, right? So you're trying to predict the yes or no. And in here, I'm saying that the number of people employed, so the employment conditions, is the most important one. I'm also seeing something here that leaked the outcome. This is the call duration time. Okay. Again, apologies, I didn't go deep into this data set, but essentially what I can see in here is that the age of the person that I'm calling does not matter, or it matters a lot less than the employment employment conditions, right? So if people are getting jobs easily or not, and market conditions. You see, I have the LIBOR rate, consumer confidence, right? So it has more to do with market and job market than it has to do with the method of contact, right? Or the age of the person that I'm calling. You see what I'm saying? So the model that was generated here, now I have ways to go back to subject matter experts or to the business owners, and I say, hey, does this make sense? Is this model that I'm creating here based on things that match our understanding of the world here, right? So I think explanations is a pretty good feature here of AutoML, and I have seen data scientists use that just to quickly throw a bunch of data in and then see, okay, which features matter in here, right? To answer question number one. And question number two, will this, can I make a quick assessment? The data set that I have, is there a combination of algorithms and pre-processing that will give me hope to continue in this project, right? Because if you get like 20, 30% accuracy, maybe you don't have the right data, right? Or in a classification where you have two classes, you get like a 50-50. So your model will be as good as flipping a coin, right? So those are the ways that I have seen this being used. With that, I appreciate that we are a bit over our time. So I want to ask you if you have any particular questions. I appreciate that I'm just scratching the surface here. But any questions, any comments, anything that you found useful or any feedback is appreciated.